Okay, in these notes, we're going to actually get to factoring a polynomial with one of the main factoring methods. So it's going to feel very similar to when we factor with the GCF, but we are going to do a little bit more. So just a reminder, to factor an expression is to rewrite it as a product of its prime factors. So we're breaking these things down, kind of reversing the distributive property into their most basic parts. So this method that we're going to look at today is called factoring by grouping, and it works for 4-term polynomials. That's important. So these polynomials have 4 terms. And so here's the basic process. We'll talk through it and then we'll do several examples. So when you have 4-term polynomials and they have 4 terms, and you can see this example right here, 1, 2, 3, 4 terms. What you want to do is mentally separate the first 2 terms from the second 2 terms. So we're going to look at each set of 2 terms separately. So in those 2 groups, you factor out the GCF of each, and then you'll see we have a common binomial then that we can factor out to finish. That probably doesn't make sense. Let's see how it works. So we have this example, x squared plus 4x plus 2x plus 8. We're going to factor this by grouping. So first we're going to consider the first 2 terms, this x squared plus 4x. Now the GCF of those 2 terms is just x, so we take an x out of those 2. So divide them both by x, we get x plus 4. And this part works just like factoring out a GCF, but we're just looking at the first 2 terms and the second 2 terms. So the second set, we have 2x plus 8. We can factor out a 2, and we're left with x plus 4. Now you can see that we have x plus 4 here twice, right? That's our common binomial. So that gets pulled out. That's the first part of the answer. And then the second part is just what's left. We have x, we have a positive 2, so that's x plus 2. And that is the factored form of that 4-term polynomial. So this is why we practice factoring out the GCF first, because it really is just that twice. All right, we have some more examples here that we're going to work through. So it says factor the following expressions by grouping. Now we want to look for an overall GCF first. So if a polynomial has a GCF overall, we should factor that out as well. So taking a look at this first one, I do not think we have an overall GCF. They don't all have x, y, or z, and 2 doesn't go into all of them, 3 doesn't, so we're good here, we can start. So we'll look at the first 2 terms. The GCF here looks like 3x, y. It's the most we can take out there. And then what's left over is 2x plus 3z. Okay, let's do the second set. This 4x plus 6z, we can take out a 2. And I like to put a plus sign in front of it. It helps for the last part. Okay, then take out that 2. We end up with 2x plus 3z. And this is what you want. You want it to be the same here and here. All right, so our first part is 2x plus 3z. And the second part is what's left over, 3xy plus 2. And that's our factored form. Let's check out example B. First, look for an overall GCF. Looks like we can take a 2 out. They're all even. 2 is the smallest one there, so 2 is the most. So let's take a 2 out of this one. That leaves us with xy minus 4y plus 3x minus 12, right? Just divide everything by 2. And now we can factor by grouping, but ignore this 2 for now. We'll have to bring it back at the end. So we can take out the GCF for the first 2 sets here. It looks like it's just a y, leaving x minus 4. And then for the second set, we can take out a 3, positive 3, which leaves us with x minus 4. And that's what we want. Again, this is the same. That's what we're looking for. So that's the first part. We have x minus 4. And then the leftovers, y plus 3. And then don't forget that 2 from the beginning. You want that to be part of your answer as well. So there's completely factored that 4-term polynomial. Example C. First, again, look for an overall GCF. I don't think there is one here. So we can just start factoring by grouping. From the first two, we can take out a 2 and an x, leaving a plus 3c. And for the second group, we can take out a b, leaving a plus 3c, which again is the same, which is what we're looking for. And then left over is 2x plus b. So once you get used to the idea, it goes pretty quick. Okay, looking for an overall GCF here. I don't believe there is one for example D. So we'll go straight to grouping. We can take out a 2m from this first pair. So that's 3x plus 2. And the second pair. Now you see we have two negatives here. And remember, when factoring by GCF, if the first term is negative, you should use a negative when you're GCF. So that's what we'll do here. We'll take out a negative. R looks like was all we can take out. And so we're left with 3x plus 2. And again, we've succeeded because we have the same common binomial there. So 3x plus 2 times, and then 2m minus r is what's left. Okay, last two examples here. Example E, we're looking for a common factor first. I don't think there is one. Now, if we're wrong about that, we'll find out when we try to group. One of them will have a extra thing we can take out of it. So let's see what happens. So first two terms here, we can take out a 3x squared, leaving us with 6x plus 5. And then for the second set, we can take out a 2. Well, we can take out a 4. And that leaves 6x plus 5. Excuse me. Once you get the first one, you can kind of plan out. So we know we had to get 6x plus 5. So 2 wouldn't get us there, right? 4 is what we had to divide by. So it can help to know what you're looking for already. So 6x plus 5 is the first one. And then 3x squared plus 4 is what's next. Okay, last example. I believe there is an overall GCF here. Looks like we can take out a 2 and we can take out a b. That'll leave 12a squared minus 15ab minus 16a plus 20b. All right, and then we want to remember that 2b, we'll need it later. So for grouping, we can take out a 3a from this first one, leaving 4a minus 5b. And then right here, the first term is negative, so we'll take out a negative 4 from this, which again leaves positive 4a minus 5b. And that's what we wanted, 4a minus 5b. So 4a minus 5b. The leftover parts, 3a minus 4. And then that 2b comes down to finish it out. All right, so that's factor by grouping. We have a 4-term polynomial that we can first look for an overall GCF and then find the GCF of each set of 2. And once you do that, you should have this common binomial that you can factor out. And then what's left over is the second binomial. And don't forget any common GCFs if you found one.